In this session, we will study three-phase transformer that to zigzag connection mode in the secondary side. The first, the zigzag connection, what I am considering here is the delta is the primary, secondary is it is a zigzag connection that to star zigzag connection in the secondary side. In the case of the primary, the windings are normally connected in delta, whereas in the secondary, the winding of each phase of a star connected winding is divided into two equal parts. That is, the winding of each phase on the star side is divided into two equal halves or two parts with labeling as shown in figure. That is, the one winding is divided into two, that is between A1 and A2 and A3 and A4. That is, it is a winding. A winding is divided into two equal parts with A1 and A2 labeling and A3 and A4. In the case of mere star connection, we have got only one winding comprised of all these windings. Then the voltage which is induced in the hull of the one of the winding is VA2A1. That is, A2 has got higher potential with respect to the A1. Whereas the voltage in the secondary of A3 and A4 is VA4 A3. That is, if it is only one winding, we are getting only one voltage between A1 and the A2, that is whole winding. But in the case of zigzag connection, the single winding is divided into two, then the voltage across is VA2A1 and VA4A3. Now, normally the delta connection, there is a normal delta connection and what I connected here with a phase sequence of A, B and C. It is A, B and the C. And here the each phase, that is phase A, phase B, phase C, these windings are divided into two equal parts. Then they are connecting in the different modes. Just how exactly you are connecting? First, half of all the phases A, B, C are connected in star. That is what I am doing here is half of all the three windings, that is A, B, C. That is, here it is A1, A2, it is half of the windings of phase A. It is B1, B2, that is half of the phase B winding, and it is C1, C2, it is half of the C phase winding. Now, the other part of the winding of A, B, C are connected here, with same phase displacement. Can look into here. That is, the first what I am doing is the second part of the B, that is in phase with this B2. We can look into here. It is a phase of the B2, then it is maintained here. But instead of connecting here for a single winding, what I am doing, I am hauled this particular winding, all the three windings in the secondary. Then the second part of B2 is connected to tip of it. Similarly, look into here, that is the half of the C winding, that is it is same phase as this C1 C2, but it is connected to the tip of the B2. Similarly, the half of the phase A which is connected to tip of the C2, that is the phase remains the same here, means what you are getting here, it is a zigzag connection. You are getting a zigzag connection instead of one winding. That is, if we are looking into this, I am marking this as A, it is a B and the C. Then each leg of the star connected is found by using half from the two different the phases. That is, we know that is this phase A is comprises of two different windings. One is half of the A and half of the C, whereas the B phase is we are getting combination of phase A and phase B, whereas the phase C we are getting the combination of half of the B and half of the C, so that the each leg of the star connection is formed by the using halves of the two different the phases. Now if you are drawing the vector diagram, first I am drawing for the delta connection. So here it is A1, A2 in the primary side, that is a phase and line voltage remains the same in the case of the delta connection. Then it is B1, B2, then it is C1, C2. Then we have what a the star, that is the reference n. Okay. Now we have got these are the terminals A, B and C. This is phase voltage as well as the line voltage of A. It is a phase and line voltage of phase B, phase and line voltage of the phase C of the primary winding. Then we have to draw the vector diagram for the secondary winding. First you have to draw for the first half of for the half winding, that is A2, B2 and C2. Just you look into that is the voltage, it is A2 here, B2 here, C2 here. The same thing I am drawing here. That is A2, that is in phase with this, B2 that is in phase with this, C2 that is in phase with the C2 winding. Then what winding we are connecting here to the C2, that is we are connecting the half of the A, that should be in phase with this. Similarly for half of the A2 we are connecting half of B2, therefore to the tip of A2 you have to add half of the B. Similarly here see, look into here, that is you can see here I am added here the A2 winding, that is what is the phase of this? It is a phase of this as A2, this is A2. Where we are adding? We are adding to the tip of C2, therefore I am adding here, that is C3, C4. It is C3, 4. Just like a third phase, it is a C3, C4. It is A3, A4. A3, A4 is added here. Then you can see here we are adding, it is a B3, B4 to the A2, therefore A1, A2 you are adding B3, B4. Therefore, it is a B3, B4 here. For B2, you are adding here C3, C4 because it is C3, C4. Therefore, what is the total, the per phase voltage we are getting? It is adding C2 plus A4 that is half of C, half of A. Therefore, these are you are representing as A, B and C. Then you can see here V1 is the phase as well as the line voltage of the primary, that is in the delta side. V2, which is the voltage of each half of the secondary, that is the voltage across each half of the winding is what I am considering is V2. That is you can see here, this is V1, V1, V1. Here it is, each half is reading V2. Sorry. Then the phase voltage of the secondary voltage we are getting by adding this V2 and this V2. Therefore, what I am getting is 3 times V2. Then if you are interested in the line voltage, in that case line voltage in the star side is root 3 times the phase voltage. Root 3 times the phase voltage. Therefore, root 3 into what is your phase voltage now? We are getting a phase voltage is root 3 times V2. Therefore, we were getting the line voltage of 3 times the V2 in the zigzag star connection in the case of delta zigzag star connection. Then, why you are doing these connections, zigzag connection? What are the advantage of this zigzag connection? That we are listing some of the advantage of the zigzag connection of the transformer. One is less costly for the grounding purpose. Usually these are used for grounding purpose. If you are comparing the cost involved in the ground as compared to the star delta or Scott connection, it is very cheaper than these two connections. And the second advantage is of connecting the zigzag connection is that you can reduce the third harmonic component which is flowing in the load side. Then the third advantage is a ground current isolation. It is also possible from this zigzag connection. Then there is an isolation from the ground connection. That is also possible using the zigzag connection of the secondary. And at the same time, there is no phase displacement between the primary and secondary circuit with this connection. These are some of the advantages of zigzag transformer connection. There is one more mode of connection of the zigzag connection. Previously, we were seen that we have got a primary side is delta, secondary star. Here we have got a primary side also star. The secondary side is also star. However, in the secondary side we have got a zigzag star connection. Once again, the secondary winding is divided into two parts. That is A1, A2. That is each phase are divided into two parts. That is A1, A2, A3, A4 for the phase A. Similarly, B1, B2, B3, B4 for the phase B. And C1, C2 and C3, C4 for the phase C. Then the voltage across each hall windings are VA2, A1 and VA4, A3. Each leg of the star connection secondary is formed by using half of the two different the phases. Once again, as in the case of the previous delta zigzag star connection, here also where each phase is in the secondary is comprised of half of the two phases. The primary is star connection, therefore I am considering a star connection. Then the voltage across each phase is V1P. I am calling this is the primary phase voltage across each winding, that is V1P, V1P here, V1P here. Then the secondary, that is I have got here A2, B2, C2, half of the A, B, C winding. To the tip of all these hall winding, I am adding, for example, for A2 I am adding B, for B I am adding half of the C, for C I am adding half of the A. Then what I am getting here is A, B, C is the lines of the secondary winding. Then how to get the phase voltage here? The phase voltage of A is voltage across this plus voltage across this. Then the vector sum of the voltage across half of the C phase, half of the A phase, that gives the phase voltage of the secondary winding, that is V2P. Here also it is a V2P here. Then this is V2P here. Then if you look into with respect to the neutral point, then this phase, because if you look into the phase voltage of the A phase is acting upwards, vertically upwards, whereas the phase voltage in the case of the secondary of the star connection, zigzag connection, the phase voltage which is shifting from the zero neutral point to the 30 degree in the clockwise direction, that is lagging in the nature. Means if we are connecting the secondary in the zigzag star connection, there is a possibility of the phase shift of either plus 30 degree or the minus 30 degree. In this particular combination, there is the lag of the phase voltage of the secondary with respect to the primary. Therefore, this connection is called as phase shift of 30 degree lag. Then what is other possible combination? Then we look into that. That is, we have got a primary star connection. The secondary, we have got the original, this is A, B, C, that is A2, B2, C2. That is, I have got this A2, B2, C2. To A2, previously what we are joined here? Half of the B phase. But in the second case, what I am doing, instead of connecting half of the B to the A, I am connecting half of the C to A2. That is what I am getting here is, it is A2. To A2 I am adding here C here. Here you are connected for half of the B, you are connecting half of the C. But in this case, what I am doing here is half of the A I am connecting. For half of the B, I am connecting half of the A. Whereas for half of the C, I am connecting half of the B here. Then here I am changed here. Previously it is for C phase we have connected A4, but here C we are connecting B. For here A it is half of the B, but here A to C. Here it is B to C, here it is B to A. Therefore, if you are once again marking the phase of A, B and C here, then if you are finding out the phase voltage, that is the sum of this voltage and this voltage, that gives the phase voltage. The phase voltage is V to P. Then if you are looking to the P to P with respect to the V1P, it is the leading. That is, it is a plus 30 degree. Therefore, this type of connection, what we are calling is the phase shift of 30 degree lead connection, that is star bar zigzag star connection. Basically these connections, they are used for I told you, to minimize the harmonic in the load current and making use of the ground purpose. At the same time, there is a possibility of the ground isolation is also possible. At the same time, as such, there is, in the case of the delta star star connection, if you are going for delta star connection, in that case there is a no phase shift in the delta zigzag connection. These are some of the advantage, thereby we are using the zigzag transformer connection.